I'll give you a simple rundown is you just create a spherical triangle in the sky. Um, you're gonna have 3 points, your observer's zenith straight up, north pole of the celestial sphere, and then of course a star. So north pole of the celestial sphere and your zenith is basically for location, and then you need the star. And using spherical law of sines and cosines, you can derive some of these equations that I show right here. Onto the software. I need to code all of these into Arduino, which is a variant of C++, but I'm actually most experienced with Java, so I had to code in Java first. So I wanted to basically test all of my math in Stellarium, basically pick a star and then see its altitude and azimuth, and then see if the right ascension and declination that I get from this function right here, this is actually the other way around. So I look for a star, get the right ascension and declination, put those into degrees, and then I use my function to calculate the altitude and azimuth and see if that's the same as Stellarium. And that's how I verified my math. Now, moving on to the hardware, I have two things, a Neo 6M GPS. It's about $9 on Amazon, so pretty cheap. It's also pretty accurate too because it's within 0.2 degrees of latitude and longitude, which is very accurate for such a cheap price. And then the MPU9250 is about $12, and that's for measuring my altitude and azimuth. It is a little bit more variable, and you have to do it outside because it'll get all messed up with, electronics. Yeah, so I can measure these with my device, connect this cord to the computer right now because it's not wireless quite yet, and the computer will insert altitude, azimuth, and then to right ascension, declination, and then back, and basically show all of its results on my terminal. Cool. Yeah, so here's the results. This is what I see on my terminal right here for both the GPS and the compass. I'd not actually see both of these because I would just store them to variables and then do all my calculations, but it will show me the right ascension and declination of the object I'm looking at. Cool. And I made sure to add up here results MPU9250 because this is with the MPU9250, and I'm working on a new compass right now that's more accurate than the one that I was working with. Yeah, so this is some of the limitations. The compasses that I used burned out really quickly, and that's not very helpful. So I'm using, I think it was called Mini IMU version 5, and every single new compass takes new code, so this one's still in development. I still have to do some calibration with it to get actually decent values, but it's looking a lot better than the other compass. So I don't think I actually showed, I think I forgot to insert my results for like my error. But with the MPU9250, the total system error, when I tested it out the field, can get your second observer to look within 5 degrees roughly of your star. So it is a little bit inaccurate, but I was using cheap parts, and I think this is a good proof concept. And I think that's about it. I said everything in the conclusion.
Hey, Charlie, thank you so much. What an awesome job. Congratulations again. And does anybody have any questions for Charlie?
Hey, B, I'll make a statement if I
Sure.
can. I've been doing this for well over 10 years, and I can tell you the technical quality of the science fair projects has increased tremendously. And this is a pretty good example of how much the quality of the work that's done. And when you see some of the other coding things with AI, I mean, this is electronics and coordinate conversion. We wouldn't have seen this 5 years ago. This is really good work.
I completely agree, Ken. I did science fair when I was in high school, and these projects blow those out of the water. This is amazing stuff, Charlie. So again, huge congratulations to you. Thank you so much for coming tonight to share your interesting project, and the best of luck to you academically in the future.
Yeah, thank you.
You're welcome.
Cool.
All right, guys, let's move along. Ken, if you can get to my slides, I think we're going to move right into the member Grand Canyon Star Party. We had a number of people from our group attend this party. I don't know if it was the biggest one, but here's the members that went. And I asked in an email, I didn't know all who attended, but some members sent in their pictures to share. And I think you're up first, Priscilla. So, Ken, if we could just go ahead and advance to the next slide and
I'm not doing it. I think Dave is
actual
doing it.
member. Oh, Dave's on it now. Thank you. Here's the group who went. Good looking group. It
Good
looks like
looking.
a lot of fun.
Except for William, who's taking the picture.
Oh no, William's not in the picture.
Oh no.
Didn't you guys have a tripod for Pete's sake? We'll have to get William in next time, but that's really cool too. William actually took it upon himself to make the banner in the background with our new logo. That looks amazing. So thanks so much, you guys, for sharing your experiences tonight. And the next picture I think is Priscilla's group. So go ahead, Priscilla, take the floor and let us know what you took pictures of.
Oh, sure. So these are just Milky Way pictures. And then I was um I was trying to figure out how to get like pictures of the Grand Canyon in the foreground, but the Milky Way in the sky. And I haven't figured out how to do that yet because this is just with my cell phone. So and then the scope in the bottom, that's the one I brought. It's the a loaner scope from the club. And it was amazing to have a 16-inch Dob out there. I was I was able to show people galaxies and um that was so fun. It was like so fun to like talk to kids because kids seem to get more interested in galaxies, and when you tell them they're looking at something like 52 million light years away, they're like, whoa, and what if someone's in that galaxy looking back at us? And I'm like, yeah, who knows? And um it was yeah, it was a really fun time. It was
Awesome.
cold this year, which
Oh,
was
wow.
weird. Yeah.
Priscilla, the next two slides are yours as
Oh,
well. And if you could advance, there you go.
okay, so yeah, this is the South Rim, much bigger than North Rim. So there was um I think like 70 or 80 telescopes out behind the visitor center. And um yeah, that's where the Milky Way kind of starts there around like 9:30, and then by like later in the night it's so cool because then it just is like a rainbow over you. Um, but that's when it's lower in the sky. Uh,
That's
do I have more or
Yeah,
I
one
don't
more
know.
slide, Ken.
Okay.
Go to
No,
the
no,
next.
no.
There you go.
Okay. Yeah. So I'll let Jose talk more about this because it's his tradition, but um, they couldn't sit us all at one table. So anyone who wants to, we do like a breakfast. And uh, yeah, Jose has lots of cool traditions he always knows the good places to eat. So and then the one on the right is that's the observatory where Pluto was first discovered at because the Lowell Observatory is really close, and that that observatory is so cool. I mean, wow. I'm like next year I really want to make sure that I like don't do an outreach event one night and do their night program because what a cool observatory. So much good like outreach stuff there. Um really really cool. So,
Very
but it was
cool.
closed, but I couldn't walk in.
Oh,
I know. But some other
awesome.
scopes there were open, so yeah.
Awesome, awesome pictures. Thank you so much, Priscilla, for sharing your experience. Next slide. I believe these are Dennis's slides. Unfortunately, he couldn't join us tonight. Such a bummer. But there they are with one of the Rangers. There's Priscilla and Jose. I think this was a solar scope demo. And then this is one of my favorite ones where Dennis was doing something in the back of his car and felt a bump and didn't realize it was actually a moose that had come to visit and get a drink of water. That's probably one of my favorite pictures. And then again, I think this is more the crew with the solar scope again. So thanks to Dennis for sharing these pics and wish that he could have been with us tonight to share his own stories in his special way. Next slide, Ken. I believe we're now moving into Prince William. You've got two slides ahead if you wouldn't mind jumping in and sharing your pictures.
Not a problem. So what I wanted to feature is that the National Park Service, for those that are up for camping, does provide us with a campsite, and the wild animals just walk right through it. I heard reports, I wasn't there when it happened, but apparently one of these elk just walked through our telescope field one evening as people were arriving. So they're all over the place. I did, however, also want to feature my group of refrigerator magnets. This year, Priscilla, I have added as a place of honor the Polaroid picture that you took. The quality.
Yay!
Look at that.
It's a terrible picture, but I'm going to treasure this forever. Look at that thing. It is so classic. And there's so much to do when you go there. I mean, you got the Hoover Dam and Las Vegas if you want to stop there on the way. The Meteor Crater is nearby, and so many places to see around the Grand Canyon and go to. It's just a marvelous trip to take, along with possibly the best skies I have ever been in for observing at night, and an appreciative crowd of people. They're just excited and having a great time, and so we have a marvelous time as well.
That's fantastic. Thank you so much, Prince William. Those are great pictures. Jose, are you in the audience? I think you are. Yeah?
Yes, I'm here. Can you hear me?
Awesome. Yes, we can hear you. And Jose, you're the next 7 slides. Go for it.
Well, just a taste of what I saw over there, or what people would see if you went to the Grand Canyon Star Party. I've been trying to go since 2008. And yes, I do have some traditions of bringing some people to eat with me. It's kind of a fun thing for breakfast and stuff. It's not very expensive, and it's at the famous El Tovar Hotel. But anyway, the seating was really good all week. We had a little bit of wind, but here's just a sample of some of the stuff that I was able to pick up. Big group picture there. My solar setup, me and Craig and the others, I think Brad and Doug Hansen and we did some solar for a couple of days. Had about 140 people each day look through the scope, so that was kind of fun. And yeah, fun for everybody.
Beautiful pics. I think you can keep going, Dave. He's got a few more. There we go. There's
the upper deck of the new Lowell Observatory Science Center. I need to go back there at nighttime. That's amazing. It seats 240 some people, and it's open and it faces the south sky.
Wow, beautiful.
We got to go back.
Yeah. One more last slide here, Jose. Thanks for sharing.
Sure. So there's just some of us, and the lower picture is when 11:15 p.m. comes, and people start to take down their stuff. You're able to stay if you want, but this is the time of the night that people pack up, and for those who want to go.
There's Prince William chilling before it gets dark.
There he is. Yes.
That's awesome. You guys, thank you so much for sharing your pictures. Maybe if you could just give some information about people that think this looks awesome and when to sign up, like when does all that happen for next year?
They have released the dates for next year already. I don't know them right off.
It's June 6th to the 13th.
Say again?
June 6th to the 13th.
June 6th to the 13th. Now you can send a message. You can message me, and I'd be happy to forward to you the TAAA's contact point. But it's also on the National Park Service. The Grand Canyon Star Party is a National Park Service volunteer opportunity. So it's actually listed there, and they link you over to the TAAA to sign up. If you're going to get a campsite, you can do that a few months in advance. The National Park Service allows us a large number of campsites there for free. Okay. If you're considering going and want to get a hotel in the park, you probably need to start looking at reserving that now. It fills up pretty fast, except for the really, really expensive ones, which I could never afford. But anyway, it's something to plan for. It's a marvelous trip. Wonderful weather every time I've been there. I think one year we had some showers come through and some clouds that hampered the scene, but most times it's just absolutely amazing skies and an amazing audience. Really, really excited to be there and look through our telescopes.
Awesome. Thank you, Prince William. Exactly the information that we needed. If you guys need more details, please find Prince William, email him, message him. Prince William, tell us how to get a hold of you in the chat group. Beyond that, let's see. We are moving along. Oh, I think next slide, Kin, is to, of course, our election. And I know this is, not the most popular topic to talk about, but we are coming upon this. And I know a lot of people, especially in the audience, have, been there, done that with the club. But we would really love for people to take a serious look for the positions that are opening up for 2026. There are 2 officer executive positions opening, the corresponding secretary and also the vice president. That's my position for election. Both of those seats are 2-year terms. And then, of course, every year the 4 director seats turn over. So despite, how many years you've been with the club and the roles that you have played, please consider joining the board because we are going in a brand new direction. There's lots of projects that are coming on board and we need lots of help. Given tonight with some of the struggles that we have still with our meetings, this is some of the stuff that as board members, we tackle these sorts of issues every day. So if you guys can, think and put some energy towards that, think about putting a bio together because our election is coming up. These are just some of the things that we always say, think about, if you know somebody or you feel yourself, this is something, a role that you'd like to fulfill, that would be very welcome. So our election is coming up and we'd want everybody who's interested to know exactly how to run for a board position, or if you have questions about exactly what board members do, please reach out. Everybody on the board's contact information, email is on the website under contacts. Okay, finally, without more delay, let me just say quickly, our next program is going to be featuring Richard Wolf Jacobson with Pi Finder. That's going to be really exciting. And we're also going to have another one of our science fair winners present their project. But tonight's featured speaker, we welcome Dr. Neil Farber, and the topic is astrobiology, the search for life. Neil, welcome.
Thank you very much. Glad to be here with you guys, or at least virtually anyway. I guess you want me to start sharing. Okay, you should be getting it there. Okay. My intent is to be able to look at everybody and have you believe by the time I'm done talking that there is a good, not only a good possibility, but likelihood that there is life elsewhere, not only in our galaxy, but right here in our own solar system. Now, a lot of you are humming, which I expect, because where in the world is there? And I'm talking about life now. I'm not even talking about life past. I'm talking about life right now, elsewhere in this solar system. And you're going to look at me and go, this guy is out of his mind. And if I haven't convinced you that there's at least a good maybe even likelihood that there is life elsewhere, not only, as I said, in the solar system, but in our own, not only in our own galaxy, but in our own solar system, then I will not have done my job.
Challenge accepted. I'm ready.
Yes,
Okay.
very good.
Dave, do you have it?
Still working on it, downloading it right now.
Okay. And as I said, a lot of does everybody understand about finding exoplanets in
Yeah.
terms of how to do it?
Yeah, we're good at that.
Okay, so I'll just I'll just pass those by. Because the rest of the data are the interesting part. I usually give this lecture to people who don't understand about things like Doppler transit, direct imaging. So I'll just zip by that stuff.
Says I got about 40 seconds left, so everybody keep going for about 40 seconds or so before
40 seconds. I can do 40 seconds.
So,
I can-
so
I-
what is your minimum criteria for life? Is it some kind of an algae-like scum?
Bacteria even.
Bacteria.
I mean, I'm not talking about intelligent life
Yeah.
necessarily. I mean, obviously, SETI is looking for intelligent life, but I'm talking about any kind of life elsewhere.
Okay. Which would be huge.
Pardon me?
Which would be huge.
Which
to have another example of biological life.
Right. And I think that probably within the next 20 or 30 years, maybe even sooner, we'll have enough data, and we may not have direct evidence in terms of like looking at a sample, but we'll have enough data to say there's no other way. Ah,
Wow.
thank you. Okay, so we're up. I'll go. So one of humankind's primary question, not the only one, obviously, is are we alone in the universe? And we can talk about two types, intelligent life or any type. Next slide. So for intelligent life, it's SETI, obviously. There are no positive findings yet based on SETI. So we can just put this aside. Next slide. Yeah. So in terms of looking for intelligent life elsewhere, there's no direct evidence of life elsewhere. But there are biologic signatures that are being sought. And this is evidence of carbon dioxide, but especially oxygen, or evidence of organic molecules, and especially certain organic molecules that give us the hint that that there really truly is life in those areas. And we can look for habitability, which there are three necessities for. Next slide. And that's basically persistent liquid, either water or another. Usually we used to think of persistent liquid on the surface of a body. That's not always true, and I'll get to that a little later. There has to be key chemical ingredients of life. And we're talking about elements like carbon, oxygen, nitrogen, hydrogen, sulfur, phosphorus, and some kind of energy from metabolism. Next slide. So we've been looking in two areas. One is in distant stars. The other is, and these are basically exoplanets, of course, or our own solar system. Next slide. So the first thing is distant stars. And as you know, there are probably at least 100 billion galaxies. Some people say several hundred billion galaxies, all the way up to a trillion galaxies in the universe. There's about 300 billion stars in the Milky Way, which is a average to largish galaxy. And so we're talking about 3 times 10 to the 22nd stars in the universe. With that, there's a good possibility of life somewhere. So far, there have been about 5,600 exoplanets that have been discovered. Next slide. So I'm going to pass these. Next slide. Next slide. Next slide. This is NASA's Transiting Exoplanet Survey Satellite Tests, which has found a lot of the exoplanets based on transits. Next slide. Next slide. Next slide. And just to point out, actually seeing exoplanets is very difficult because of the fact that they orbit the star, and it's anywhere from 1,000,000 times to up to 10 billion times fainter looking for the exoplanet compared to the star. Next slide. But it actually can be done with the coronagraph, which, for example, the James Webb Space Telescope has. And if this is an actual video based on that, and if you see the central yellow star look like thing, that's the coronagraph. But those 4 dots that are orbiting it are exoplanets that have been seen. Next slide. And next slide. So we've discovered, like I said, about 5,600 exoplanets. Okay, go ahead, hit it again.
Hey, Neil, just for grand, Neil,
What?
I've given you slide control. It's a new feature in Zoom.
Oh,
Why don't
okay.
you click on the slide and see if you can change it.
Okay. No,
Okay.
doesn't look like it. Hit it again. So for planet characterization, we want to know, does it have an atmosphere? Next slide, or whatever. What molecules are present in the atmosphere? Could it support life? And then finally, does it have life? The does it have life? It's going to be a while. But there's a lot of habitable zone stars, but planets are either too close and the surface is too hot, or too distant and it has no liquid water on the surface. And the only way we can look for life on exoplanets is looking at the atmosphere. So it has to at least give us a hint that there's water on the planet, on the surface of the planet. There have been several hundred planets found in the habitable zone, but not all of them have been investigated yet. There's one planet that was found with CO2 I'll talk about in a second. None with oxygen so far. And this is just the habitable zones. Next. TRAPPIST is one that we're going to be looking at because it has 3 good planets that are in the habitable zone, D, E, and F, or actually E, F, and G. D is sort of in the borderline of the habitable zone as well. So it's at least 3 or 4 planets. They're rocky planets. They could potentially harbor life, but we have not gone there looking yet so far. But that's a possibility. Next slide. Hubble did find water on 30 planets with water vapor, but they were too hot for actually liquid water on the surface. Next slide. However, the James Webb Space Telescope has come up with something interesting. Next slide. So this is about a few years ago, a couple of years ago. It was pretty early in James Webb's history. It was in 2023. It found K2-18b, which is about 120 light years from Earth. This is a planet that is in the habitable zone of a star. It's it's a rocky planet. It's about somewhere between the size of Earth and Neptune. It has a very large amount of water on its surface. We know from looking at the um, the 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 planet through James Webb on the spectroscopy. Um, and early on, it found the possible detection of dimethyl sulfide. Now, if you look at dimethyl sulfide on Earth, it's found only as a metabolite of living things. For example, marine algae, certain plankton that feed on dead fish, those kinds of things. And it gives the kind of fishy smell at the ocean. And we've never found it any other way on Earth. But we weren't sure that really was there. I mean, there was controversy about whether it was really found or not. Some poo-pooed it. Well, more recently, a few months ago, there was an article published where they used James Webb again, focused on K2-18b one more time, and found a tremendous amount of dimethyl sulfide. They're talking about larger amounts percentage-wise than the amount that would be in Earth's atmosphere. And they also found dimethyl disulfide, which is another biologic metabolite. The only thing they need to do is confirm the fact that dimethyl sulfide and dimethyl disulfide cannot be produced any other way. And if they find that, then basically we have a really good indication that at least one exoplanet has life on its surface. Okay, what about the solar system? There's possible evidence of previous ancient life on Mars that I'll talk about. There's habitability in other bodies, and we'll talk about what that means, but no actual life has been found yet. Next slide. So Mars, you guys may all know this, so I may be just talking to the converted, but Mars, the early rovers had a suggestion of, even the early rovers had a suggestion of water. They found outflow channels, layers of rock, indicating probable sedimentary rock. It could have been due to multiple windstorms, but it sure looked like the presence of water. And Curiosity confirmed the presence of water. And we now know that Mars had water for about 1 billion years until about 3.6 billion years ago. And this is in the Gale crater. Perseverance also confirmed the evidence of water in the Jezero crater. Next slide. So Curiosity showed that there were sedimentary rock all around it. Its landing site was made of pebbles. All the pebbles were rounded, and the wind on Mars is really too weak to have rounded pebbles. You're talking about 10% of the wind of the atmospheric pressure of Earth. That is not enough to really round pebbles. So it's pretty clear that the erosion was due to liquid water. And again, further away still, there's extensive sedimentary rock seen. The water also was low in salinity, though there was some salt in it, and a neutral pH. So it was a really good habitable environment, and it was relatively young on the planet, which indicates that there was a good possibility of life having formed there early on in Mars's history. Next slide. The other findings were the spectrometer from Curiosity that the building blocks of life were present: carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur, and there was complex carbon-based molecules present. Now, unfortunately, the spectrometer on Mars is not complex enough to be able to indicate what kind of carbon-based molecules they were, but they were at least complex carbon-based molecules. And keep this in mind, because there's something else I'll tell you about later that pretty clearly indicates that these were the kinds of things you would expect with life. They could mean two things, though, from the information we have so far. And that means it could have happened naturally, or they could have been biologic in origin. Next slide. And this is a photograph taken from Curiosity. Basically, you can see the sort of layers of sedimentary rock, which clearly indicated that there probably was a water-based environment. Also, there were clay-bearing units, which again brings up water, and a hematite-bearing unit, which again brings up water. So it's likely that there was free-flowing water on Mars at some point in time. Next slide. And those are the rounded pebbles I was talking about. Next slide. Another thing that sort of gives us a hint that there was water was this was a rock that was accidentally hit by Curiosity and broken open, and this is pure sulfur, which forms usually in, again, liquid environments. Next slide. Perseverance, which landed in February of 21 in the Jezero crater, its landing site was a river outflow channel in Delta. It's the best place to look for ancient life because of the fact that you have water coming off the hills and depositing silt as it flows into a shallower area. And so Perseverance has been drilling for core samples and placing them in titanium tubes for later collection and return to Earth. Next slide. And these are the eroded stones at the landing site that Perseverance found. Next slide. Now, this is one thing that is, for all the world, looking to me as a former biology major in college and physician, eventually for 40 years, looks all the world to me like a bacterial mat in this rock. And it's studded with this stuff. It has a darker ring around it and then a lighter central area. Now, presumably water with some kinds of dissolved solvents could do this, but so could either bacteria or mold or fungi or something like that. So we don't know for sure until it comes back to Earth. It is in a tube, it's waiting return. Next slide. So as I said, Perseverance are collecting these samples. It was planned in the 2030s to have a return mission. It's not sure what's going to happen now, given questions about funding, but hopefully somebody at least will be able to collect these samples, bring them back to Earth and study them. And the plan is to determine if these are organic samples or are they biologic. Next slide. And this would be the return mission. Perseverance would go up to the lander, deposit the tube that you see hanging there, which is put into a return vehicle. It's lifted off from the Martian surface. It docks with the Earth return vehicle, which then would return the canister, which is reentry proof, back to Earth, just as this sample was returned from Bennu. Next slide. Well, there are other bodies in the solar system that could potentially have life. Now, no other body has free water that we know of, because none are in the habitable zone. But they do have some of the chemicals needed for life, and they might just have the energy, not from the sun, but from another way, for having life on inside their body. And I'll talk about that. Next slide. Europa is the prime example of this. It has 2 times the ocean that Earth does, but it's below an ice crust. It's way out of the habitable zone, but it does have that liquid ocean, so it has energy. And it has also plumes of ocean water that are spraying out of the surface through cracks in the crust. It has a rocky mantle, and so it has plenty of minerals needed for life. So let's put this together. Next slide. This is Europa's surface. If you look at it, it's not a nice shell completely. You see dark material, and that probably is goo consisting of both mantle as well as organic material. Next slide. This is a cross-section of Europa's interior, and you see that basically the ocean is throughout the entire subsurface of the planet, which is why the ocean is actually twice the size of Earth's oceans combined. Next slide. And if you look at Earth, Earth is not a water world, it's a rocky world. All of Earth's ocean water consists of that little sphere that is off to the upper right on the planet Earth. Whereas Europa, it's almost half the size of the planet. So it truly is an ocean world in this case. Next slide. And this is the how basically it's able to have a liquid ocean beneath an ice shell. It's basically tidal heating. Because of its eccentric orbit around Jupiter, causes a great deal of flexing, which causes friction, which therefore causes liquidization of the ice to consist of water, as well as melting of the upper part of the mantle, allowing some mantle to be spurted into the liquid water. Next slide. Okay, so this is a video of hydrothermal vents at the bottom of the Pacific Ocean. This is real, it's live, not live, it's recorded, but it was taken live. You see the material being spewed into these vents, but if you look close, you see all kinds of critters crawling along these vents. There are some 3,000 species of algae, tube worms, crustaceans, all along these vents. About a third of those species have no connection with life above on the surface of the Earth. Now, what does that mean? Does that mean that these are aliens? No. What it means is that there's a good possibility that life, and next slide, that life formed, at least some aspects of life formed in these hydrothermal vents. Some scientists believe that all life on Earth might have originated at those hydrothermal vents and then migrated upward instead of forming in the tidal pools on Earth and then migrating downward. But whichever one you believe, that no one can refute the idea that at least on Earth, life formed, some aspects of life formed in those around those hydrothermal vents. And since the same kind of setup appears to be present on Europa, why not having life form down in those hydrothermal vents in Europa? So the idea is to send a spacecraft here to see about habitability and see what we can find. Not necessarily life, but at least habitability and perhaps organic molecules indicating the possibility of life. This is Europa Clipper. Next slide. I had the privilege of going to JPL and seeing it being put together. Next slide. And it's one of the biggest probes ever sent to any planet. Next slide. And this is it in the high bay. Next slide. It launched in October of 24 last year. It'll take 6 years to reach Jupiter, doing gravity assists. It'll orbit Jupiter with swings, about 50 swings around Europa, and it'll do that for about 2.5 years. The reason for the swings is due to the high radiation. As I said, its mission goals are to determine definitively habitability, not meant to determine if there's actual life. Wink, wink. A lot of the scientists don't believe that. They believe it is to look for life as well. But at least to determine habitability, determine is there organic material present, look at the consistency of the ocean, and look at possible sites for future landers, rovers, and the snake that's being developed at JPL to go down through the cracks and actually look for life. Next slide. Ganymede is Jupiter's largest moon. It has a huge ocean underneath its ice shell, bigger than the one on Europa, which also abuts rock, but unfortunately there's no evidence of hydrothermal vents, so it's on hold for right now. Next slide. And you can see there's no material on the surface, so there's nothing being spewed out. Next slide. But the ocean is clearly there. Next slide. Titan is Saturn's largest moon. It's far beyond the habitable zone, but it's similar in some ways to Europa. Next slide. Next slide. You know about Titan. And next slide. Although Titan does have organic haze layers in its atmosphere, so it's sort of like an organic factory there. Next slide. This is a sort of artist viewpoint of Titan looking at Saturn. The liquid you see is all liquid methane and liquid ethane. So because of the coldness, some people think that there could be a possibility of just enough energy to have liquid ethane and methane act as the liquid solvent for life. I'm not so sure there's enough energy really though. But, next slide. There is an ocean below the crust, same way as on Europa. And here there's also cracks in the crust. And since you have so much organic material on the surface, it's a perfect way for organic material to get into that liquid and start life there. Next slide. And so the Dragonfly mission is predicted to launch in July of 2028. It'll arrive in Titan on 2034. It's a lander that has flight capabilities. And so it will explore both habitability as well as prebiotic chemistry using spectroscopy. Next slide. And this is a model of the Dragonfly lander, and you see the front of it is a large sort of suite of instruments, but there are rotors on multiple sides in order to be able to attain helicopter-like flight, similar to Ingenuity, except that Titan's a lot easier because it has 1.5 times the atmosphere that Earth does in terms of pressure. Next slide. Enceladus is also one of the smallest of Saturn's moons. It does orbit closer to Saturn than Titan does, and so it does have sort of the same tidal heating. In this case, it has geysers with ammonia-rich water. Next slide. This is Titan. It looks like an ice shell. Next slide. But it has all that stuff spraying out. Next slide. And Cassini, which looked at Titan as one of its pass-bys, showed a large amount of dihydrogen, which is evidence for hydrothermal vents like those on Earth. It has an abundance of carbon dioxide and methane, and there are new findings of phosphate in the plumes, and phosphate on Earth is part of DNA and also involved in energy transfer. So there's a distinct possibility of Enceladus being also a site of life, again, in its ocean beneath the ice shell. And so NASA has plans for a flagship mission sometime in the 2030s, which would be an orbolander, meaning an orbiter and a lander. Next slide. So Uranus and Neptune, we only got a quick look at that by Voyager 2 in the 70s. We don't know if there's any kind of liquid there. Next slide. Next slide. But Uranus has 5 moons. And given the fact that it's a large planet and the moons orbit fairly closely, there could be tidal heating with liquid oceans in these as well. That'll be sometime way in the distant future, probably the second half of this century. Next slide. But the conclusion is that there are lots of ocean worlds across our solar system, and several of them may harbor life. Next slide. Now you have to ask yourself, how in the world could the material get into into the water with, yes, there's energy, but that's not enough to form, probably not enough energy to form these compounds. I mean, we think that the compounds like RNA, DNA, amino acids formed because of the radiation from the sun. At least that's one of the thinking, one of the ideas about it. Well, there's some new data that can explain all of this and can also help explain how life started on Earth. The Japanese spacecraft Hayabusa 2 explored Ryugu from June of 2018 to November of 2019 and returned a sample of the, asteroid, it's not a comet, about 5 grams worth. Next slide. And one of the things it found was uracil. If anybody remembers their biology or was a bio major, uracil is one of the bases that make up RNA. It's the one base that's not included in DNA. It replaces, don't ask me to remember which one, I think cytosine, but I'm not sure. But anyway, it's one of those bases that is in RNA. And that was kind of startling to people. Next slide. But OSIRIS-REx returned and analyzed a bigger sample of carbonaceous material from a carbonaceous asteroid, Bennu. And its spectral interpretation provided information of the entire asteroid population, which means basically it's any carbonaceous material, any carbonaceous asteroid is going to have the same kind of material. Next slide. And this was OSIRIS-REx taking a sample of Bennu. This is how it did it. And it's not really this is just testing it out on Earth. Next slide. Next slide. Now, Bennu is a smallish asteroid. It's about half a kilometer in size. It's a spheroidal asteroid with a spinning top, but it's carbonaceous. Next slide. And recently, the material has been analyzed. Next slide. if anybody recognizes this, these are the 20 amino acids that are required for human life. Of the 20 amino acids that are in us, 14 of these were on the surface of Bennu. I'll stop there for a minute and let you ponder that. Next slide. Even better, these are the 4 bases that make up DNA. Okay, thymine, adenine, guanine, and cytosine. All 4 of these, in addition to uracil, were found on the surface of Bennu. So it is likely that anytime there is an asteroid that splashes down in something, be it a planet like us or Mars or Europa or anywhere else, it seeds that body with all of this material. And that's probably how life started, and probably could have started life anywhere in our solar system. Next slide. Next slide. That's DNA. Next slide. So in summary, there's no evidence of intelligent life, but there's so many planets in the universe, it's likely, and we're getting close with K2-18b. No, again, no definite evidence of life in the solar system, but boy, there are plenty of planets and moons with habitable conditions, and a lot that are beginning to give us tips that maybe we'll find life within the next 20 years. Next slide. And I'll answer questions.
Feel free to unmute and ask questions if you guys want to.
If no one
And,
has
and I will accept challenges as well.
no, I don't. I remember naval aviators on aircraft carriers saying that there were biological life forms that could grow in aviation fuel, and they would clog the filters basically.
Mm-hmm.
I'm sure they were scummy little,
Mm-hmm.
multiple single or multiple cell organisms.
Right.
If that is really true,
Mm-hmm.
what kind of trajectory would life living in gasoline look like?
I mean, scummy little things is right. They're basically going to be bacteria or something similar. It wouldn't be more than that probably, but who knows? I mean, then you got to think about, well, if they're living in gasoline, they could probably live in ethane and methane, right?
For Titan.
Yeah, on Titan. So yeah, it could be on the surface.
Fascinating presentation. This is really quite cool.
Yeah.
They so on Enceladus, are they? I've heard talk about planning a mission specifically to Enceladus. Is that going to? Have you heard anything along that line about what they're going to do?
I haven't heard anything about any mission because of, I mean, I'm supposed to not get into this.
Politics.
I'm not getting into politics. I'll only state that NASA was planning on slashing NASA's budget in half, with most of the slashes being oriented towards STEM education and unmanned missions, which might postpone any unmanned mission, be it the Mars return mission, be it the Enceladus orbit lander, or even the Dragonfly mission. So I don't know where any of this is going to be. It depends on what Congress decides to do with that line item. If they just pass it as is, it's going to be a while.
Unfortunate.
Unfortunately. And the only thing I can say in answer to anybody's question about what can we do is just talk to your congressman. I'm allowed to say that.
We have seen briefs on an eel-like device.
Yes.
could make it down from JPL, that could make it down through the vents
Right.
to some level and probably get some measurements and find out what's going on. If you were in charge of NASA and had all the money in the world, would you think that would be the best place to go exploring?
You bet your sweet bippy. Right after we get the data back from Europa, Europa Clipper, and assuming that we see habitable conditions and organic material, that's where I would go next. Yes. I would also send the Dragonfly mission too, though.
The Titan.
The Titan, yeah.
Are there any missions looking more at the processes of life than just the components of life?
What do you mean by the processes of life?
Basically, if you think about the biochemistry pathways, right, that
Right.
life is based on, all the different molecules has to interact, has to, modify each other in order for life to achieve multiple states of energy redox levels.
Right. I think the first thing would be to see enough indications like DNA, amino acids, actual organisms, if you see it. That would be the first step. The second step would then be to analyze how they function.
But that presupposes, sorry, go ahead.
But think about the fact that basically, if we do get close enough and can actually say we know there's life on blank, that's like a game changer. That's the biggest story, probably the biggest story in human history.
Yes, that certainly would be. But I think one of the problem with the notion of life is that we only have one instance of life that we know of, right? The life on Earth.
Right.
And but there's nothing saying that life in space or out there somewhere will actually have to follow the same biological processes, right?
Correct.
And that's why I was trying to drive at is they may not be based on DNA or RNA, even
Right.
or even they have amino acids, but is it going to be protein or some other variant form of that, right?
True, although we do know now that Bennu, which is an asteroid, has DNA and well, at least the basis for DNA and RNA on it. So
right.
Presumably that's found elsewhere as well. But yeah, as I go around and give this talk, I'm always asked about the Horta. For those of you who don't remember Star Trek, it was an alien species that was silicone based. Yes, that is true, and we can't predict what we're going to find, but we can only look based on what we know, and so far as we know, liquid is required, be it water or ethane or methane or whatever, but liquid is required, energy is required, and various chemicals are required. So, we have to start there and work from there on up.
Yes, I agree.
Unless you're a Star Trek fan, in which case Hortas will exist and we will find silicon-based ones. Very good, Alex. Yeah. Proving the background here, buddy.
Right.
Okay. Let me ask you one of the real tough questions, and that is, let's assume that there is a habitable planet and there's some form of biological life, and we can detect the chemical changes in their atmosphere that can only be caused by life forms and not other geological processes. How do we really have the ability to detect such conditions with reasonable scientific certainty?
Well,
So it could only be life, not something else.
right. So we've already detected on K2-18b that there is, as I said, there's dimethyl sulfide and dimethyl disulfide. At least on Earth, the only way that happens is with biologic life.
Okay.
Now, they're experimenting to see if there's other ways of doing this, of creating it. That would happen naturally. But assuming that we don't find any easy way of doing that, we've detected life on K2-18b.
Got it.
In terms of others, in terms of our solar system, it's easier because we don't have to just look at the atmosphere. We can go down into the planet and get samples. At least look at it with spectroscopy and maybe even bring back samples. So it'll be easier to do.
Mm-hmm. Either the swimmers or the fossils.
Right. Right. Mars does, the other thing about Mars, and I didn't mention this, Mars does have liquid water below its crust. They've discovered it with, I think with looking at either it doesn't have magnetic fields, I guess based on not spectroscopy, but based on its geologic functioning or something. But they did find liquid water actually. So presumably if there was life on Mars in the distant past, it would have migrated somewhere where it could still exist, which means it could still be existing below the crust.
Wow.
Not impossible.
Dr. Farber, can you explain some theories about how the building blocks for DNA ended up on an asteroid?
That is the question of the day. I don't think anybody knows for sure. The theory, the way the theory, well, one of two possibilities. Okay. One possibility is the asteroid. We think this asteroid was present from the beginning of the solar system. Okay. But if we're wrong, and this was an asteroid that was part of a planet that got destroyed, maybe that planet had life on its surface. I don't think that's the case. I think the more likely thing is a lot of these asteroids have carbonaceous material, and if it's being exposed to the radiation from the sun over a billion years or multiple billions of years, it would be enough energy to create DNA and basically what would have been life, except for the fact that there isn't any water or atmosphere to speak of. If you remember, Harold Urey, he was a chemist, experimented with trying to create life, or at least DNA, back in the 1960s, I think, because I met him in college, and he had already done those experiments, I think. So it would have been the early 1960s. He experimented taking a bunch of goo, putting it in a jar and exposing it to like electricity or something like that over the course of a year, and just had more goo. He didn't have DNA or RNA or anything that he hoped to find. Well, first of all, he was just exposing it to electricity, not to solar radiation. And second of all, he was probably off by about 1 billion years. But keep it up, and I don't see why it wouldn't happen.
The best challenge question I could think of, and I think I'm piggybacking on you, Ken, your first question. How would we even know if life already exists outside of water?
That is a good question. We wouldn't. unless we, well, for example, when we get to Titan, okay, we'll be exploring a world that is ethane and methane, liquid ethane and methane on the surface. And so if we see processes that look like it could be from life, then we would know that would be the case. Other than that, we wouldn't know. And all we can do is look at the things we know, because we don't have the ability to see how something else could function, although it certainly could, potentially anyway.
Yeah. Something more highly evolved, perhaps.
Perhaps.
Fascinating topic.
Thank you. Yeah, it fascinates me. That's why this is my favorite talk. I guess maybe because I was a bio major in college, so it's like getting back to my roots.
Right, right. Yeah, it's really interesting. Any more questions, guys?
Okay, let me speculate a minute, if because this really is fascinating. And if we know our model of life on Earth, and the real question is to going from single cell species up to very complex organisms, it seems to take a long time based on our model of the Earth and so forth. Do you think that's necessarily that time scale is necessarily the standard, or could something happen more quickly and interrupt that? And we've been thinking about all these very slow processes, and maybe there's a little bit of single or small, multiple bacterial level, protozoan level life. But could it happen faster, or are we stuck with this long evolutionary model?
We only know the evolution on Earth.
Yeah.
Presumably, if there were a lot of evolutionary pressure, survival type pressures, it might encourage faster evolution because of the fact that especially if it's an organism that's having a lot of mutations. So it could be faster. I do remember when I was in college being told that life had to exist on Earth only in the last 400 million years. We now know that's total crack. Total crack. Life existed on Earth probably about 3.5 billion years, maybe more. It just was single celled most of that time. Which, so certainly Mars had enough time to form life. Whether it's more advanced, who knows? But it's hard to know what's happening on another planet. Are there environmental pressures that make it happen more quickly, or are there, for example, one thing might be if there's more radiation than we get, there would be more mutations. And the more mutations you have, the more likely you are to evolve more quickly. So it's a possibility.
That's interesting.
Yeah.
Of course, if the conditions were warm and all the little guys in the scum were happy, then there wouldn't be a competitive pressure to evolve.
True. True. Yeah, all this is amazing stuff. I think if I had to do it over again, there was no astrobiology when I was in college. What I would have done instead of going into medicine, maybe, would have been to go into marine biology. And then when the time was right, I could have leaped into astrobiology for NASA. But this is still good now.
Yep, very interesting. Are there any more questions? Well, thank you so much, Neil. This was really great. Super interesting. Thank you so much.
My pleasure.
And with that, we'll conclude our meeting. Thanks for coming, everybody.
Thank you.